so we're now going to look at how to solve quadratic equations when we have complex roots involved. So as you can see here, if this b squared minus 4ac, so that's called the discriminant, remember, if that is less than 0, the quadratic equation will have two distinct complex roots. So let's think about the word distinct, meaning they're different from each other. Complex meaning they'll have both real and imaginary parts, neither which will be real. Z squared plus 25 is equal to 0. Now, just as a heads up, so we normally would use x for real numbers, n for integers, so z is what we typically use when we're dealing with complex numbers. It's just the notation that we tend to use. Z squared, we're going to take that 25 away, so we get z squared is negative 25. That would be the normal step we do. And then you get to the part where we need to then square root the z, and we also then have to square root the negative 25, and we end up with this solution here. And this is where we normally say we can't do the square root of negative 5, so it's got no real roots. So in this case, we can say, well, actually, let's figure out what that imaginary root is going to be. So let's separate z, so our root negative 25, let's separate that out into the square root of negative 1 times by the square root of 25. The square root of negative 1 will be I, the square root of 25 is I, so we get an answer of 5i, and I realise I should have put plus or minus here, because there will be two solutions. Remember, we have two distinct complex roots, which I forgot to do. But when we do that, we end up with plus or minus 5i as our answer. Because when you square root, it's always going to be the plus and the minus as well. So let's now have a look at how we would solve that equation there. So we can't factorise it, but there are other methods that we can use. So let's first of all look at completing the square, because we can definitely do that. So let's see, to do that, we would take this bit here, that becomes z plus 3 over 2 squared. And if you expanded that out, you'd end up with z squared plus 3z, and 3 over 2 squared is 9 over 4. So remember, we need to get to 5, we've got 9 over 4. So we need to work out what we need to add to 9 over 4 to get to 5. So if I'm just going to do 5 minus 9 over 4, which is 11 over 4. So that's what I would need to add to that to make it equal 5, and therefore be the same thing as what we started with up there. So now let's have a look at solving that for z. So first of all, I'm going to subtract that 11 over 4. So this will now become z plus 3 over 2 squared is equal to 11 over 4. Then let's square root this. So that'll give us 3 over 2, and this will give us plus or minus, whereas that's a negative 11 over 4, because that's the whole point of this. So that'll be plus or minus the square root of negative 11 over 4. Now, this is a point where we need to think about how we're going to get rid of that negative, so we need to think about how we're going to get I in there. So what you can do here, if you remember, is you can actually rewrite this and put the square root over the numerator and denominator individually. So I can actually say that's actually the same thing as the square root of negative 11 over the square root of negative 4. And hopefully you can see why I've done that, because this bit here now, I can then just write that as a 2. So what I can do now is I can rewrite that and say, well, the square root of negative 11 is the square root of 11 times by the square root of negative 1. So that will become root 11i. And then the root 4 will become 2. So now I can say that z plus 3 over 2 becomes this, plus or minus the square root of plus or minus the square root of 11 over 2i. So then let's just take away the 3 over 2. So z is equal to plus or minus root 11i over 2 plus 3 over 2. And if you wanted to, you could swap those around so the real bit comes first and the imaginary bit, but it shouldn't matter. So another way in which you could solve that is by using the quadratic formula. So z squared plus 3z plus 5 is 0. So b is 3, a is 1, and c is 5. So we end up with minus 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times 5, all over 2a, which is just 2. I just realised as well that should be a minus 3 over 2, not a positive 3 over 2, because we took away there. We can already see here, hopefully, that this bit here, minus 3 over 2, that bit we can just rewrite. Minus 3 over 2 plus or minus root 9, and then that will become minus 20 over 2. Root 9 minus 20 over 2. And then if we do 9 take away 20, that's going to get us negative 11. So now we end up with minus 3 over 2 plus or minus square root of negative 11 over 2. And then the square root of negative 11, we can rewrite that now in terms of I. So this whole thing now becomes root 11i over 2. And if you notice, that is the exact same thing we got before when we did completing the square. So then the final method I'm going to show you is via the calculator. Now, to do any sort of complex numbers using the calculator, there are a few steps that we need to follow. So we're going to get our calculator. What we're going to do is enter matrix mode, so just press 1 for matrix mode. Then you're going to press Shift and then the menu button where we can see setups in yellow. Then you're going to go down to complex mode. You can see real, so it might be in real for now. So we're going to press A plus BI, and that will mean we are in complex mode now. So there's two ways we can do this. We can actually just input the quadratic formula and that should work now. So minus 3, we'll do plus to start with, square root of 9 minus 4 times 1 times 5 over 2. So there you go, we've got one of our solutions there. So we have minus 3 over 2 plus 11 root 2i, root 11 2i, and then let's do the minus, and there you go, get your other solution, which is minus root 11 over 2i. Another way you can do it is you can do the equation solver here. So if we go on to equation solver, we're going to do polynomial, f2, 2 degrees, there, and then so z is z squared plus 3z plus 5, and then solve, and there are two solutions, minus root 3 plus 11i over 2, and the other one, minus 3 minus root 11i over 2, and there are our solutions. So you can use a calculator, but it's important that we also know how to do that without a calculator as well.